Consider the normalized state of a particle in one-dimensional harmonic oscillator, which is described by this linear combination of two states, 0 and 1 which denote the ground and first excited state of the harmonic oscillator, and L1 and L2 are the constants. The expectation value of the displacement in the state will be minimum. So the four options are given, which gives the relation between L1 and L2. So to relate L1 and L2, let us introduce the constant alpha. L2 equal to alpha N1, and instead of L2 I am writing as alpha L1, taking L1 common. And since the wave function is normalized, psi is normalized, so bracket notation of psi into psi will be 1. So using this relation, L1 and plus L1 square plus the square of the expansion coefficient L1 and L2 will be equal to 1. L1 square plus L2 square will be 1. So L1 square, taking L1 square common and substituting L2 square as alpha L1, we get L1 square into 1 plus alpha square equal to 1. So now finding the expectation value of x, we are substituting for bracket psi into psi. So we will be getting 4 terms. So when we are writing ket vector, vector of psi, L1 into 0 plus alpha into 1. So how we are getting 4 terms? Multiplying L1, we get L1 square, and alpha into alpha, we get alpha square, 1 into 1. Third term, L1 into alpha, we get L1 square into alpha, and alpha into L1 we get the fourth term. Okay, so as 0 and 1, the ground and first excited state of the harmonic oscillator has a definite parity, odd parity or even parity, and x is a odd one, x square will be even. Here x is odd, so 0 into x into 0 or 1 into x into 1. So will be the 3 terms combination will be, the parity will be an odd parity. So integration of this odd parity will be giving 0. So the two terms, integration of these two terms will become 0. Remaining we are having 2 terms. Here the coefficient are L1 square into alpha. So the expectation value of x, both the combining this, we are having L1 square into 2 L1 square into alpha. Instead of L1 square, let us substitute 1 by 1 plus alpha square. So we get this expression. So expectation value of x directly proportional to 2 alpha by 1 plus alpha square. So we want to minimize expectation value of x. To find this, we are using this condition, differentiating with respect to alpha and equating it to 0. So using u by v method, denominator we are having 1 plus alpha square the whole square, differentiating 2 alpha 2 into 1 plus alpha square minus 2 alpha into 2 alpha and equating it to 0. We are having 2 plus 2 alpha square minus 4 alpha square equal to 0. So which gives 1 minus alpha square equal to 0. From this alpha equal to plus or minus 1. So we are having two values for alpha. Which value gives minimum of expectation value of x? Let us find. For this, substitute the value of plus 1 in the expectation value of x. We get 2 by 1 plus 1, that is 1. Substituting alpha equal to minus 1, we get minus 2 by 2, that is minus 1. So minus 1 is minimum. So alpha equal to minus 1 gives the minimum of expectation value of x. So our option is option D.